we've talked about this a bit. What's the difference between a recursive and an explicit sequence? So they can both describe the same sequence, um, but they're two different types of formulas. So it's a way of calculating the following term or a term in the sequence. A recursive formula calculates it using the value of the previous term, or it can use more than one previous term to calculate the value. An explicit formula calculates each term directly without using recursion. So this formula, this sequence might not be something that you immediately recognize, but we've studied enough to understand what's going on here. If we look at it from the recursive point of view, we're thinking of how can we go from one term to the next. So the recursive formula says, first of all, the first term is 3. Says that. It always starts with whatever the first term, or maybe more than one term. And then, what's a rule that will allow me to get to the next term? Well, here I'm adding 2. Then I add 4. Then I add 6. So I'm adding these even numbers. So to get to the second term, I'm adding the first even number. So maybe we can phrase this like this. To get to the n plus 1th term, I'm going to take the previous term, 3. I'm going to add the second even number, 2n, to it. So I'm adding the second even number, or the first even number, to it. And then here, this is the third term. So like a sub 4, 15, is equal to a sub 3 plus 2 times 3. Which is 9 plus 6 is 15. So this is an example. What you would need to define the recursive formula is these two things. An explicit formula, on the other hand, goes entirely in a different direction. It does not care about how to get from the first term to the second. It just cares how you get from n to the term. And this one requires a little more finesse to do in this case. And I believe the explicit formula is a sub n is n squared minus n plus 3. So, for example, a sub 3 is 9 minus 3 plus 3, which is 9. If we wanted to look at that term, 1, 2, 3, 4, 5, 6, 7, a sub 7 is 7 squared minus 7 plus 3, which is 45. Oh, good. Things worked out the way that I thought they did. So this is the difference between an explicit formula and a recursive formula. In blue, you see what's boxed is the explicit formula. Here's the recursive formula, both describing the same sequence. Why do we use both of them? Well, one, the recursive formula is faster to find the next term, whereas the explicit formula is easier to find a random term. So if I want to find the 6th term, use the recursive. If I want to find the 800th term, you want to use the explicit formula. It's usually easier to find by humans. Humans typically find a recursive formula faster than they're going to find an explicit formula. But once we have an explicit formula, it's usually easier for us to analyze it and graph it, and we could you probably don't have a really good sense of what this pattern is, but you definitely have seen a lot of quadratics and should know how to graph that. So these are the benefits and pros and cons between them. In general, we have not learned how to convert between them. But we do know how arithmetic sequences look and how geometric sequences work. So this is this is the recursive formula for an arithmetic sequence. This is the recursive formula for a geometric sequence. Now it should also tell you a sub 1 is something, and here a sub 1 is something. The explicit formula doesn't need that extra piece of information. These are the explicit formulas. But if I give you this explicit formula, first of all, you need to know that it's arithmetic, and second, you should be able to figure out, oh, that is going to be this in the recursive formula, and that, and instead of writing a sub 1, we'll write a sub n minus 1 here. Or if I give you this recursive formula, you should be able to produce the explicit formula that goes along with it. You should also know how to evaluate recursive sequences for the next few terms, as well as how to evaluate explicit sequences for any random term. So here, if I give you the recursive formula, you should be able to tell me what the next term in the sequence is. Well, let's add the next even number. Here we were adding 14, so here we're going to add 16, and we would get 75. But using the explicit formula, I would expect you to be able to say, what's the 100th term? And you can say that that's 10,000 minus 100 plus 3. Here's a recursive formula that is not straightforward. A sequence is described recursively such that a sub 0 equals 1, a sub 1 equals 2, and a sub n equals the previous term raised to the term 2 before it. That's interesting. Determine the values of those next 4 terms. So let's do this systematically. A sub 2 is going to be the previous term, so that'd be a sub 1, raised to 2 before it, a sub 0. Well, what's a sub 1? It's 2. What's a sub 0? 1. So this is 2. Okay. A sub 3. Well, that's the previous term, raised to 2 terms before it. The previous term was 2. We just found that out here. 2 before it, a sub 1 was 2. So that gives us 4. So far we have 1, 2, 2, 4. A sub 4 is the previous term raised to 2 terms before it. The previous term was 4. 2 terms before it was 2. So 16. A sub 5 is a sub 4 raised to the a sub 3. Again, this is n is 5, so 5 minus 4, 5 minus 1 gives us 4, 5 minus 2 gives us 3, which is a sub 4 is 16, a sub 3 is 4, and 16 to the 4th power, I'm going to take out my calculator for that one, 16 to the 4th power is 65,536. Not quite as obvious. Definitely hard to come up with an explicit formula for that. But I do expect that you can read these rules clearly enough to determine how to find the next few values.